One possible thing you can do with systems of equations is you can add or subtract all three columns straight down. Here's what I mean. X plus a negative x gives you 0x, which we don't even really need to put, but we'll put it there to hold the place. Next column is the y column. We have 2y plus y gives us 3y. I'm putting the plus because it stays positive. The numbers on the right, 3 plus a negative 2 gives us 1. This 0x goes away. And to solve for y here, we would just divide by 3, and we would get y is equal to 1/3. We could then plug this back into another equation. Let's see what happens when we try to subtract straight down all three columns. We have 1x minus a negative x, which gives us 2x, 2y minus 1y, which leaves us with 1y, and 3 minus a negative 2, which brings us to 5. The problem here is that we still have two variables, so it's impossible to solve. We could plug in a couple different numbers to figure out x and y. X could be 2 and y could be 1. X could be 1 and y could be 3. There's no definitive solution until we eliminate one of those variables. That's why the first step here is we have to figure out which one should we do, add or subtract. To figure that out, you look at the coefficients of the variables. You'll notice we're trying to eliminate the x variable here. Why? Because they both have the coefficient of 1. If we add them, we'll get 0, and that variable will be eliminated. If we subtract them, we won't. We won't have accomplished anything. Let's try number 2. Again, on the left, we will add straight down, and on the right, we will subtract straight down. 2x plus 2x gives me 4x. Negative 3y plus 3y gives me 0y, which will go away. And 8 plus 4 gives me 12. I can divide by 4 on both sides, and I get x equals 3. On the right, if I take 2x minus 2x, that gives me 0. Negative 3y minus 3y gives me negative 6y. And 8 minus 4 gives me 4. The 0x cancels out. I can divide both sides by negative 6. And if I reduce, I get y is equal to a negative 2/3. In this case, either way will eliminate a variable. If you'll notice, the x coefficients are 2 and 2. They're the same. And the y coefficients are also the same, 3 and 3. Either one would have worked to eliminate a variable, adding or subtracting. For number 3, let's first take a look at the coefficients. For the x variable, they're 6 and 6. And for the y variable, they're 5 and 7. Which variable are we going to try to eliminate then? And the correct answer is x, because they both have a 6, so the coefficient is the same. So we want to get 0 to eliminate the variable. Let's try adding or subtracting and see which one works. 6x plus 6x would give us 12x. That's not going to cancel out anything. But if we did 6x minus 6x, that gives us 0x, which is just going to go away. So therefore, because subtracting allows us to eliminate x, we're going to subtract all three columns straight down. 5 minus a negative 7y gives us 5 plus 7, or 12y. And 4 minus a negative 20 gives us 4 plus 20, or 24. If we divide by 12 on both sides, we get y is equal to 2. Looking at the coefficients for x, they're different numbers. Adding nor subtracting will eliminate that variable. For y, they both have a 3, and they're also both negative. So let's try adding or subtracting for the y terms and figure out which one will give us 0. On the left, if we take negative 3y plus a negative 3y, that will give us negative 6y, which is not 0, so we don't want to add. On the right, if we take negative 3y minus a negative 3y, that's the same thing as negative 3 plus 3, and it gives us 0y. That's what we want. So we can subtract all three columns straight down. 2 minus 3 gives us a negative x. And 13 minus 15 gives us a negative 2. This cancels out. We divide by a negative 1 on both sides. And we end up with x is equal to 2.